Question 5, two events A and B such that the probability of A happening is 0.33, the probability of B happening is 0.45, and the probability of A intersection B happening is 0.13. So that 0.13 can go in there. That means that if all of that is 0.45, I'm left at 0.32 here. And if all of this is 0.33, then I'm left at 0.2 here. And if I add that, and that, and take it away from 100%, I end up at 0.35 out here. So they, in part 1, want me to find the probability of A union B. That is the probability that either A or B occurs. Well, A union B is 0.2, 0.13, plus the 0.32. Altogether, that gives me 0.65. So that's part 1 done. Conditional probability is part 2. They want me to find the probability of A complement given B complement. That's the probability of A not happening given that B hasn't happened. Well, I'm definitely going to write down my formula here. Probability of A complement intersecting with B complement all over the probability of B complement happening. So that's, where does A not happening intersect with B not happening? Well, A not happening or A complement is that. B not happening is that. Where do they intersect or cross over? Well, it's out here. So that's the 0.35 on the top line. And the probability of B happening, B not happening is this here. So that's A not happening, B not happening, or A complement, that's B complement. So where they intersect is the outside here, which is the 0.35. And then probability that B doesn't happen is this, which is the 0.2 plus the 0.35, which is 0.55. And you can put that as 7 over 11 if you put it into your calculator. So that's part 2. Part 3, state whether they are independent events and justify your answer. So I have a formula for this. If they are independent, the probability of A intersecting with B is equal to the probability of A times the probability of B. If I fill this in and this is true, then they are independent events because it fulfills this formula. So A intersection B is 0.13 and the probability of A happening is 0.33 and multiplied by the probability of B happening is 0.45. And if you put that into your log table or into your calculator, 0.33 times 0.45. Okay, they're not equal, therefore A and B are not independent events. And then part B, they say event C is such that the probability of C happening is 0.2. So I need a new Venn diagram because I need to have to put in a C here. Now it also tells me that A and C are mutually exclusive. So if I put it in here, it means there is no crossover, they don't intersect, or the intersection is empty. So I actually could even put it here if I wanted, because it doesn't have to intersect with A, they're mutually exclusive, but it will intersect with B because it says B and C are independent events. So that might be helpful later on. But my diagram I'm going to go with first. I'm going to go with one that looks normal. I normally don't see the last one that I put in there. So I'm going to go with the A, B and C. I'm aware that these two will be blank. So that's A, B, C, and I'll fill it in again where I had 0.2, 0.13, 0.23, no, 0.32. Now I don't know actually whether that 0.32 should go here or where. So they tell me that B and C are independent. Now, if they are independent, that means that the probability of B intersecting with C is going to be equal to the probability of B times the probability of C. That's true when they are independent, and it says they are, so I can use this information. So the probability of B intersecting with C is the probability of B times the probability of C, which is 0.09. Now that means that I can put the 0.09 in here, because that's the probability of B intersecting with C. Now that means that I'm left here not with I had a 0.32 up here, I now have 0.23. And here, all of this is 0.2, so I'm left with 0.11. And all of this should add up to 100%, so I have 0.24 out here if you add that up and subtract. And these are just empty here. I don't need to do this, but I'm just highlighting it to you because they told me inside in the question that they are mutually exclusive, so it means there is no crossover. A and B can't happen, or A and C can't happen at the same time. Part 2, it says find the probability of B union C complement. Well, B union C is this. B union C complement is just what's left, which is 0.2 plus 0.24, which is 0.44.